Hello, welcome to the New Stack Makers, a podcast where we talk about at-scale application development, deployment, and management. The New Stack thanks the Code team for sponsoring our podcast from KubeCon CloudNativeCon in Austin, Texas. Learn more about the open source projects Code is supporting and its team of passionate open source engineers and advocates building community through contribution and engagement in emerging technologies. Learn more about Code at thecodeteam.com. Hey, it's Alex Williams, the New Stack here, live at KubeCon plus CloudNativeCon, and I'm here with two distinguished people from the community. Why don't you guys introduce yourselves just to say hello?
I'm Josh Bernstein, the VP of Technology from Dell Technologies.
Hey, Kit Colbert. I'm CTO of the cloud, what am I? Cloud platform business at VMware. I changed my role so much I can't keep it straight anymore.
Those acronyms get to you after a while.
Well, yeah, we do have a lot of confusing and similarly named BUs within VMware.
Right.
So anyway.
Can you name all 11 of them?
Yeah, but don't ask me to right now. No, but I used to. So I used to do all the cloud native stuff at VMware. So it was the CNA BU, which I almost said, but I was like, no, different BU now.
Right. So what acronyms are we going to talk about today?
Well, it depends what you want to talk about.
How about CSI?
We can talk about CSI.
But I want to talk about more in a context of kind of like what we're seeing in terms of deployments out there and like how Kubernetes is actually getting deployed. Are you guys actually seeing it deployed, and how is it being deployed? I'm curious about that.
Yeah, absolutely. Well, we're seeing tremendous interest in Kubernetes, right? And I think what you're seeing is the industry really coalescing around it as a standard. You know, you look at the last few years, and there's been a tremendous amount of activity in the space, a lot of excitement from customers, but then also some uncertainty as to where, what directionally, where is it going, what should customers make a bet on in terms of investing their time and effort into. And now, so Kubernetes is now pretty clearly the standard. Like all the big companies and vendors are behind it. And so we are starting to see a lot of customers starting to think about it now. I myself, I don't believe, have I seen anyone in production? I don't think so. I think companies
define production, right? That's what it is. Like.
Yes, most of the customers are still kind of at the kicking the tires phase, trying to think about how they're going to implement it. A lot of questions around what sort of technologies should they be looking at. Kubernetes solves a bunch of problems for them, but obviously doesn't solve everything. So there's a lot of other stuff they need to do around Kubernetes. And so right now, yeah, still a lot of thinking, a lot of activity, a lot of kicking the tires, as I said. Not so many production deployments yet, but I think they are coming soon.
What's slowing it down?
I think the biggest thing is people are trying to figure out actually how to deploy it and in what context to deploy it. There's Kubernetes and setting it up, but there's also the automation of deploying it on-prem, on bare metal. I think you're seeing a lot of projects pop up to deploy Kubernetes on virtual machines, and I think part of that is due to the fact that when you deploy something in the cloud, you're really deploying a virtual machine, and so there's a lot of tooling around that. And I see a lot of the Kubernetes stuff pop up in the cloud first, and then when they bring it back on-prem, the easy thing to do is to look at your virtualized environment on-prem and use the same semantics you're using to deploy in the cloud on-prem. And so I see a lot of people kicking the tires with Kubernetes on top of VMware because that's what they know and love, and that's what's in their data center already.
Yeah, I mean, I think, so the challenge with containers, Kubernetes, any of these things, is not in dev tests. We see it a lot in dev tests. People are leveraging it, people are taking advantage of it. We see, containers being a very common way of building the CI/CD pipeline around these sorts of things. When you go to production, though, that's where it gets really hard, because now you have all these production operational requirements.
You got to have security at some point.
Yeah, security, like monitoring, how do you deal with storage, how do you deal with compliance issues. So there's a lot of those problems you start getting into. And again, with these newer technologies, there's not established solutions yet, not only from a technical standpoint, but also from a best practices and really, conventional wisdom standpoint either. So I think that's kind of I wouldn't even say slowing it down, per se. I would say this is a natural evolution anytime you have a new set of technologies.
I also think that, like as you said, Kubernetes solves a lot of the operational challenges of running applications, but when you move to production, there's all these sort of ancillary ecosystem challenges that haven't really been fleshed out yet. You build a CI/CD pipeline, you kind of demonstrate you've got it up and running, and you can run some stateless applications. But when you move things into production, you have to be able to do security, you have to do network automation, you have to do load balancing, service discovery, you have to do persistence, you have to be able to store data, and I think that that, those sort of ancillary pieces are what's been missing from the ecosystem for so long. And now, even at this show with the container storage interface, and I know you've worked with CNI, for so long in the past, we're starting to see these like peripheral problems come, have solutions for a lot of these peripheral problems.
We had a breakfast this morning, and there was one.
It was way too early in the morning, by the way.
It was, we'll have a pancake breakfast at noon for you.
That would be great if we could have a noon or pancake lunch.
How about pancake dinner?
How about breakfast for lunch?
Breakfast for lunch or dinner.
I would be there for that, right?
Definitely. That'd be amazing.
All right.
Good.
Good idea.
So one of the persons said, it's not like you can SSH into a server and just find out what the problem is, right? But now there are these lifecycle of applications that kind of surround the whole environment that help you that help you see a different kind of a picture, and it becomes a matter of trust, whether you can actually trust these applications, because there's blind spots that you really can't see unless you have these applications, in your environment itself.
I think the point about like SSHing to a server is just, it just seems sort of like a cop-out, right? I mean, when you operationalize any sort of scale of application, having dashboards and analytics and visibility into the environment is absolutely critical if you're going to be successful at running it. SSHing into a server is kind of like a crutch, but when you have 10 servers or now 100 servers all of a sudden, like even if you didn't have Kubernetes, even if you didn't have this, you're not going to be successful operationalizing that environment without something. And you see this just amplified more when you move into the distributed space. And I think VMware's done a great job in this space for a long time. When you have a whole bunch of VMs, you could still SSH to them, but that's not actually enough, right?
Yeah. Well, I think you bring up a good point about trust. I think that people had to get familiar with the tools. They have to trust the tools that they're going to do, what they say they're doing. And the whole topic of monitoring is a really complex one. And as the applications change in architecture as well, they become distributed systems. Lots of new problems emerge. I mean, distributed applications are really hard to build and to do correctly. And yes, there are a lot of great new technologies that can help us to solve some of those problems, to contain a lot of that complexity. But nevertheless, understanding, if there is a performance problem, where is it coming from and who's impacted, and then how do you fix it, can become very, very tricky. And so I think that's the other thing, when people look at, I'm going to go run this in production, they have to think through, how am I going to solve that problem? And again, there's a number of solutions out there, but they're still fairly early, and so there might be some extra work you need to do to make it successful.
And I think that, you made a good point, like the nature of microservices is that the applications are more distributed, and so it's much harder to do that diagnosis and track down those kinds of problems.
Yep.
So then we're starting to see ways that we're starting to see ways that our attempts, I think, at simplifying it, right? So CSI is an example of that, right? So we're seeing service mesh technologies emerge, right? But each of these have trade-offs. Well, I mean, there are trade-offs with everything, but are these the, I wonder if these are the answers, right? Are these the answers that people are looking for? Are they looking for that glue? Are they looking for that simplicity?
Absolutely, yeah. So I think, I look at it a couple of different ways. So on the service mesh side, I think it's a tremendously powerful technology. And again, another one of those areas where it can actually simplify a lot of what you do by encapsulating.
But you have to trust it. You really have to trust the mesh.
Well, and then like the question is performance. What sort of throughput can you drive through a service mesh?
That's what I'm wondering.
Yeah,
I don't today.
Yeah, I don't know actually. I've not done any analysis on it.
Are there performance degradation?
You'd have to imagine there are.
I think it depends upon how the mesh is implemented. If it's implemented as full proxy, then anytime you go through a proxy, you're going to push a bottleneck. But there are plenty of service meshes. There are plenty of service discovery pieces that are API call based, and they don't get in the way of the data plane.
Yeah, the data.
And in that case, there's maybe an extra bit of latency to look up the service, but there's not a performance hit. You can still drive the full amount of traffic through it. It just depends on the implementation.
Right.
But I mean, that's not a reason that you shouldn't use a service mesh necessarily.
Yeah.
Like we know that like Lyft, for instance, uses Envoy and at massive scale.
Right.
So they're maybe able to mitigate any sort of performance issues that are there. But the point being, I guess, that again, because it's so early, there's not a wide base of knowledge around this stuff, and to really examine those trade-offs, right? And so I think that's what we're kind of as an industry discovering. And so we'll learn that as an industry, and people will be producing blogs and white papers and so forth forth about it, but again, it takes time, and people have to try and fail in various ways and learn things, and so it's just a natural evolution.
Yeah, we've been talking about this for a while though, and I'm curious about that because there's been a lot of discussions over the years about being doing more rapid innovation and and iterating more quickly and and being much more focused on continuous development, but it still hasn't happened. And
yeah, I think it's happening, but I think that a lot of people are still applying sort of a legacy approach to developing. As engineers, we want to research everything and then we want to formulate a plan. And when the space evolves very, very quickly, the advice I give to people is like, stop reading and go try it, go deploy it, go run it. We had this conversation about configuration management systems several years ago. Well, which one is right for me? It actually doesn't matter. You just need to pick one and stop talking about it and go learn. And I think the more that the community adopts sort of the try and fail and try again kind of mentality versus here's this broad structured plan and we're going to go execute on that. And I think it's just a product of the way cultures are organized inside of large companies. I come to Kit and I say, here are the PowerPoint presentation that I've spent the last 6 months working on, and I'm going to go build this. And Kit says, yes, you may. And then 2 months in, I realize I made a mistake, but very rarely do I go back to Kit and said, hey, I made a mistake. I need something else. Like, instead, you just kind of soldier on because you want the project to be successful. And I think it's that mentality, that idea that you have to do something materially different before the whole industry is going to shift.
Well, I think, yeah, and I totally agree. And I think, so the other challenge that we're seeing in the cloud native space, to your point about how applications are developed and the whole process there, is that the fundamental challenge is not a technology challenge; it's a people and process challenge.
Yeah, that's right. It's a culture.
Exactly.
It's culture more than anything else.
And those, as we know, that's always the hardest problem to fix, right? And we're seeing that across the board. And a lot of customers are struggling with this because you do have to institute some pretty radical shifts. The whole notion of service ownership, for instance, is a radical departure from how software was developed and where the accountability laid before. So like with the concept of service ownership, the team that builds that service is now responsible for it functioning properly. And all the other components or teams within the company can support that team, like they can build a CI/CD system they can use so that team doesn't have to work on that. But in the end, that team is accountable for their code running in production.
Right.
And so and once they start thinking that way, now they're going to have to weigh that trade-off. Does it make sense to check in this change if maybe there's some risk they'll have to get up at 3 a.m. to fix something? They naturally balance those sort of trade-offs. But and it requires changes as well in terms of responsibilities, like what does ops do versus what does development do, and there's going to be some mixing there. So these are the big challenges that we're seeing.
It makes me think about kind of the changes that actually have happened, and in many ways, through the client-server era, it was about the machines and the infrastructure that you had on-premise. And you would then configure those machines, and and you had to learn new ways to configure those machines, as you speak to, right, with Puppet or Chef or whatever you used. But now it seems like a little bit different, where now it's not exactly about the machine anymore. It's really about the application.
Yeah, or the service, right?
And so it seems like this is a shift that hasn't really happened, that we have, because we could say that, virtualization really just made that client-server kind of environment just more optimized. And
it was about consolidation, right? That was the whole story.
And I think the other important point about virtualization, one of the reasons that VMware was able to be so successful so quickly is because you didn't have to change the people process part of it, right? Virtualization slid in instead of the process stayed the same. Normally you'd order a physical machine for that workload and it'd take 8 weeks to get the physical machine. Now you can create a VM. It takes like 4 seconds. But that whole end-to-end process was still identical. And what we're seeing now is that shift that we talked about. This notion of everything gets turned around. You have to have capacity, available beforehand. When someone requests something, you got to be able to immediately respond to it. These sorts of things. And so this is the big process shift that's happening.
Yeah, I think that we probably haven't seen a shift like this in the industry since client-server. In the whole mini-computer era, where people were consuming a service remotely over a serial console or a serial cable, and I think that was a cultural shift for people. I wasn't really involved in it, maybe.
No.
But I think but I think that when you go through a change like this that requires a culture shift, it's much harder. And the shift onto virtualization was really about consolidation, but didn't change real process.
Yeah.
It changed the infrastructure.
Yeah.
It changed the way you thought about building things.
And it gave you like a lot of powerful software abstractions.
Yeah, this was great
for automation, things you didn't have before. But yeah, fundamentally the process stayed the same.
But I think with containers, what's gone on is
It's application centric.
It's application centric, and what it does is it really separates more of the application responsibilities into a smaller bucket. When you have a VM construct, you have the kernel, you have the OS, you have the file system, you have all those bits on there, and that's a responsibility between the ops people and the application people. And so the container is really a shift in that, and it requires a cultural shift to be successful.
It's funny because you think about it in terms of how that's changing almost everything too, because concepts that related to TCP/IP have corollaries to service mesh technologies, but there's not exactly the same, right? The role of the on the people side, you have the role of the traditional role of the operator, but it's not exactly the same anymore. Now people are talking about, SREs, right? And so it seems to be that's a big part of it as well. It's not just, it's the language, it's the constructs.
And I think we're moving in the right direction there, right? We're moving up the stack. The abstractions are getting higher and higher level. So the example of the service mesh, it's like a service mesh is, it's a network. It's thinking about networking, but in a very different way. It's not thinking about bytes.
A network engineer necessarily.
Yeah, it's not bytes or IP addresses, right? It's about services and endpoints and like connecting those things. And so it's a very different way of even thinking about it. And what it allows you to do is to manage a much greater scale, and without some of the fragility that you have with just traditional networking.
IP port numbers. Yeah.
Exactly, that sort of stuff.
So there's somewhat of an inertia. Would you describe it as an inertia?
Sorry, how so?
Well, it's just like there's like this, like you're saying, there's like this inertia, like because it is so new.
Yeah.
It is so complex in a different kind of a manner.
Well, I think the benefits are there, but you're right. It's how do you embrace those technologies and then make sure that you're successful with them? Because the thing is, any time, like if you look at the history of this space, and you think about companies like Google or Twitter and any of these companies, right? And a lot of companies like say to themselves, or when I talk to them, I'm like, oh, well, these companies are different. They started out being cloud native. And actually almost no one starts out being cloud native, right? If you remember Twitter back in the day, they had the fail whales left, right, and center. Their infrastructure couldn't scale because they didn't have the right sort of software abstractions or architectures. And then it took some brave folks in there stepping up and saying, we got to fundamentally change how we do things. And, so that sort of shift happened at these companies, and that's why they're able to remain successful, because they made that shift. And I think now we're seeing the same thing starting to happen in, kind of quote unquote everyday enterprises or companies.
The question that I have is for the companies that you work for, these are big. You guys work for a very large corporation, and there's a lot of practices internally there that I imagine are similar to what the customers are facing.
Absolutely. We both work at big companies. We're, also customers of the community as well. And this movement from, very vertically integrated applications into more microservice-based architectures internally is absolutely something, I know we're going through, and I'm sure it happens there too.
So are you trying to adopt Kubernetes internally?
Absolutely. Yeah, we have like every enterprise, we've got a ton of different. We've got Kubernetes, we've got Mesos, we've got Docker. Different teams are doing different things, and it is like the cloud native space itself, a bit of the Wild West, right?
And I think that's okay, for everybody to be.
It should be.
Yeah.
I think, what I tell people, both internal teams as well as customers, is, there's this trade-off between what I call speed and coherency, right? It's like you can go really fast, but each team's going to go fast in their own sort of direction. You're not going to have any standards. But if you try to standardize and say, let's have everyone use Kubernetes, that will slow everyone down because they got to wait for that standard implementation to come out. So what we typically say is let the individual teams go do their thing. Again, with the service ownership model in place, they can choose whatever technology they want. When there is a standard, like we have an internal Kubernetes service and Mesos service actually, the teams can leverage those standard services, but maybe it doesn't have all the bells and whistles they want, but then they don't have to run those services, right? Someone else does. Or they can run their own thing, but now they're responsible for it.
Right. Service ownership, right?
Well, that's the whole thing. It's the beauty of service ownership is that it puts the incentives, it aligns the incentives just right, so that these product teams have to weigh all the different trade-offs. They can't externalize any sort of pain or failures, right? That's all on them.
and I think what you see is, we've divided, IT ownership in terms of, the compute, network, and storage. It was broken down by the hardware, and if you apply an abstraction of ownership, if you will, to a service or to an application, then I think it changes the way people think about writing an application, deploying a service, and supporting a service. No longer can they just, throw the application over the wall and expect everything to work and have them to be off the hook.
And that's exactly, that was the problem before, right? The developer would just check in the change because it's like, not my problem. I'm not getting up at 3 a.m.
Yeah, they're not on call.
Yeah, by aligning incentives, then they can make these balanced decisions. And so within VMware, we do have a lot of teams going off doing their thing. We have some teams that are leveraging the common implementation. And like everyone, we're still trying to figure out service ownership. We've got it going in some teams, we're getting it going in other teams. So we're learning just like our customers are, right? And we're trying to take those learnings back to our products and how we engage customers as well.
So that seems critical. It really seems critical to be able to understand by your internal learning, how to develop modern applications, and developing your own microservices, and then starting to really kind of embrace it from that perspective. That must be a story then you can carry through to the customers. Then.
Yeah, I think that you learn by doing in this space. We talk a lot about we talked about this the other night, that this idea that software engineering has this idea of engineering it, that it's an exact science and it's we understand all the variables. But software engineering is more of an art than anything else, and the way that you get better at it is you practice it over and over and over again, and you learn. And I think that's the advice that I give internally is which one should we use? Well, you should either use all of them and have all of those resources marching towards something, or you should just pick one and learn. And if you make a decision to switch later on, at least you've gone through that learning process. And I think that message resonates with customers quite a bit. I think actually, the evolution of the cloud and the shift towards the cloud has really it fits into this service responsibility space, because for the first time, people can deploy a service and not necessarily care how the underlying infrastructure works. And so people are adopting this mentality and adopting this culture without even knowing it, I think.
Yeah, and I think, the other cool thing about the cloud native space, a lot of the space excites me tremendously because we're just getting fundamentally better in many ways. Again, the service mesh, higher level of abstraction.
Storage.
Much easier to manage at scale. A lot of the storage abstractions coming in, the ability to, Kubernetes can't and doesn't need to solve all these issues. They can kind of externalize some of those, storage persistence is a very complicated subject and very tough thing to get right. And we have solutions, both of us, in that space, and the CSI integration allow people to take advantage of that. But it goes all the way to application definition. You can now declaratively define this application, how it should be provisioned, what it's using, and the infrastructure can just take care of it automatically. I think that's another fundamental improvement that allows you to automate so much more and to manage.
Yeah, back in the day, you would go meet a new application owner and you would say, how many IOPS do you need for your application? And they would say all the IOPS. How many gigs, how much gigs of space do you want? They're like, I want all the gigs. Well, now that abstraction is in place, where you don't even have those conversations anymore. You're just talking about supporting the service
for each person on the team.
No, they say things now. They say, well, I need 3 instances of this, 3 instances of this, and I need some storage for these sorts of things. And here are the mount points, or here are the publishing endpoints that I want, and here's how they connect together, and I'm done. You don't really talk about all the gigs.
Yeah.
Right.
Yep.
Yeah.
So how do you think about then? We talk about all these different kind of ways that you can build these modern applications, and storage is still very difficult. Kind of as how to think about it. You talk about persistent, data as a real complexity for people.
Yeah.
Maybe we could look at it again from internally, how you're thinking about it, because you guys have been working very hard on CSI, for example, and and building that out. How is that affecting your own thinking about storage and kind of in this new application landscape?
Well, I think, the push for me personally for storage is based on experience. You deploy a very large container environment, you go, oh, I forgot the data someplace. And what really happened was, you wouldn't forget the data. You'd like, well, I'm just going to schedule this container specifically on this node because those disks have that data.
Yep.
And when you take a step back and you look at the elegance of that solution, you realize it feels almost hypocritical. We've taken 2 steps forward, but left this idea behind.
Yep.
And so bringing storage forward and bringing away way forward to provide an abstraction between container orchestrators and storage providers is really powerful. For our customers, they have choice between a variety of products, and I think we should empower them to be successful regardless of what they already have on the floor or what they be considering, and they shouldn't be making decisions about which product is integrated better. Like, the integration should be commonplace, and the products and their features should compete and stand on their own. And that's really, I think, internally what CSI has been about for me is you don't want to purchase a product because, well, this one is not really what I want, but it's integrated with what I need. Open source's value, the whole value it brings to the table is integration. And if you can integrate a product, and you can integrate all the products or a lot of the products, then it provides that abstraction that I think is really important.
So what's the difference between integration and extensibility?
Well, integration is the idea that two things connect together, and extensibility is that you provide something that can be extended for value. So with CSI is an integration. We want to provide an integration between a container orchestrator like Kubernetes and vSAN, right?
Yep.
And it's there for the vSAN and those business units to extend, and it is extensible. Mm-hmm. But our team's focus has really been on the integration. Let's make it work. Let's make it work really well. And then if we add interesting features like replication and snapshotting and some other data service that the product provides, that's the extensibility part of it.
So is Kubernetes then an extensible environment?
Absolutely. I mean, yes, broadly speaking. I think.
Would that mean then storage is an extensible aspect of Kubernetes?
Okay, go for it.
So I would say overall, this is from our experience as doing product development. We've done extensive work both with Docker, the product or the technology, as well as Kubernetes, and the differences between the two in terms of how difficult or how easy it is to work with those technologies are very striking. We found Kubernetes to be, on the whole, very well designed, very well architected. So it's been much, much easier for us to insert our technologies and our value into the Kubernetes stack compared to what we have with Docker. Now, Docker's gotten a lot better in the last year and a half. But the ability to plug in your own networking, the ability to plug in your own storage, a lot of these things are really important. So let me just tell you a quick anecdote here. About some customers. So we have this technology called vSAN. What vSAN does, basically it's like it's a virtual storage system that replicates data across nodes with just local disks, allowing that local disk to kind of be available across the cluster. And we really envisioned this for applications that didn't have any sort of replication of their own, maybe traditional databases, these sorts of things. And you would imagine naively that distributed databases, things like Mongo or Cassandra, that do replication themselves, wouldn't need to run on top of vSAN. Like, why would someone do that? Because both things replicate.
Right.
And but what we found is a lot of customers do actually run Mongo and Cassandra on top of vSAN. So we're like, that's interesting. So we went and asked them, why are you doing that? And it turns out, going back to kind of the original question, because of operational production challenges. Like, for instance, and I'm pretty sure this is true. I've tried to research it. I'm pretty sure it's true. But by default, neither Mongo or Cassandra has any sort of data integrity validation. There's no checksumming. It's like, how do you know if random byte on the SSD goes wrong? Like, you don't know, right?
Right.
That's kind of, which sounds insane. People don't believe me when I say it, but I'm pretty sure it's true. Maybe they have enterprise editions that have it, but things like encryption. What about wanting to encrypt data? Or what about it is a distributed system, replicating data all over the place. How can you understand performance issues in analysis? What if a NIC is randomly flapping and causing weird?
That never happens, kid.
Never.
We don't drop packets. Nobody drops packets anymore.
What we found is that these technologies, Mongo and Cassandra, are great, but they didn't have all these capabilities, and customers needed those in order to run. And so when you think about doing Kubernetes, okay, yeah, you could go and use Kubernetes and just use local SSDs and use Mongo, but then you need to build out all those other enterprise production capabilities. Right. And so this is really the power of that integration and extensibility, is being able to leverage great technologies that are out there.
And I'll add to that a little bit. Yeah, it's true. Like, Cassandra and Mongo do their own replication, but they do their own replication to a static node. So from an operational standpoint, or from sort of an initial deployment, you go, look, all the data is replicated. But in an operational sense, what happens when you lose that node? If you lose the node, you lose the data. Well, you don't lose the data, but Cassandra still,
for a while, yeah.
Cassandra still wants that node to come back.
Yep.
So if you interoperate with a vSAN or a Scale.io or some other software storage on the back end, you can actually move that data to a different node logically. You can represent it to a different node, and that solves the operational challenge of highly available or high availability.
Just think about
or any reliability.
Yeah, some of these things are just ridiculous. Like, if you're just using local disks, physical disks like normal, and you run out of capacity, you have to like run around the data center, try to find that node and jam in like your new SSDs in order to add capacity.
That's right.
It's just kind of like insane, right? Whereas with vSAN and some of these other virtual storage technologies, you just call an API and the thing magically gets more disk. And so, the operational challenges cannot be underestimated, and I think customers are seeing that, and that's driving some of that utilization. But I think also the benefit for Kubernetes is that if someone already has, let's say, vSAN in their environment, all those problems are just solved. It's one less thing, or not one, there's many less things they need to think about. And again, I think that's really where we're trying to help customers. It's like, look, you guys have a lot of work to do, and a lot of things to do to get this thing running in production. Again, all those different operational requirements, let's take care of a bunch of those for you, right?
So when you think about this and think about, I'm thinking about, for instance, stateful environments, right? And how you think about that, and it's not exactly natural in a Kubernetes environment, right?
To be stateful?
Yeah.
I think that many years ago there was the document
there's
published.
Sets, and you can use it, do things that way.
But Kubernetes has this concept of data and persistence. I think what's interesting is that from a resource scheduling and planning standpoint, while we can now interoperate with storage, we still don't treat storage as a first-class resource. We treat like compute, and we treat memory like a first-class resource. But from a scheduled standpoint, storage is not. And I think maybe that's because that with something like CSI, it allows that resource to be a little bit more elastic. Like, there's not going to be a technology that allows you to consume CPUs that don't exist across the box. I mean, there is in the high performance space, but storage, I think, is unique in that you can take disks and you can take resources from disparate machines and combine them together into one pool, and that's what makes that resource different. And it's built into Kubernetes to have this notion of persistence, and there wasn't for a period of time.
Yeah, I look at it again as an evolutionary thing. Look, you got a new technology and it has a lot of benefits, and you got to start somewhere. So you start with the applications that are going to be easiest to move there, and those are traditionally the stateless applications.
They're also lower risk generally too, right?
Absolutely. Again, like, data persistence, it's nasty and very, very hard. Like, they've shown that even with fairly advanced storage systems, you introduce one bug, like one byte that's incorrect, and it kind of trickles through the entire system. And so it's like, unless you're 100% sure this thing's rock solid, it's like, you really want to be careful there. So I think it's natural that initially, people didn't focus on state just because there's so many other problems to solve. But as the maturity has increased, and as we are looking to broaden the scope of applications to support, now we're really dealing with it head on. So I think there's a lot of good innovations coming in that space.
I can't help but think, I wonder, and maybe you guys have some parting thoughts on it, maybe picking up the conversation another time, is storage a first-class citizen here in the CNCF world?
I certainly think it is. I think if you look at all the work that's gone on with CSI and all the work the CNCF has done to support it in the storage working groups, we had 60 people at a face-to-face meetup around CSI earlier this week. I think it's really being respected and really being treated as a first-class citizen. CSI will be in the Kubernetes 1.9 release. Macersfield will ship it later this month. And now that we finally have this interoperability and this integration between the two, I think the types of applications and the class of applications that are going to be shifted on this platform are much higher stakes, much more important. I think moving into next year, what do the future deployments look like? I think we'll see a shift out of sort of the dev test and onto production-facing workloads.
Yeah, I would say it is. Look, I think, again, when a lot of the stuff started a few years ago, it was just focused on compute, really. Kubernetes always had the notion of like labels and like network request routing type stuff, but what we're really seeing is both networking and storage being built out and getting much more mature. And we see a lot of companies, a lot of startups in the space, a lot of mature companies as well delivering products here. So absolutely, look, we're all, all the vendors are in this together in the sense that like we're all trying to help customers run these applications in production. So these are problems that you have to solve.
Right.
And so so I think it's getting the attention it deserves. As we talked about, it took a little while to get there, just simply because it's the natural maturity curve, and you had to solve these other problems first before you can get to these harder ones.
Well, I think, to echo Kit's sentiments, like a rising tide raises all boats, and that's kind of the point that we're in the industry is competing solutions come out, and as they get integrated down into Kubernetes and the rest of the container orchestrators, I think we're on that innovation curve, and at some point, the tide will have raised, and we'll see how the rest of the industry shakes out. But a rising tide, that's really, I think, where we're at.
Yep, absolutely.
Well, thank you, Josh. Thank you, Kit, for taking
for
some
having
time
us
to talk here at KubeCon 2017, and I'm sure we'll talk again soon.
Thanks, Alex.
Thanks
Cheers.
for having us.
Thanks for coming.
The NewsStack thanks the Code team for sponsoring our podcast from KubeCon plus CloudNativeCon in Austin, Texas. Learn more about the open source projects Code is supporting and its team of passionate open source engineers and advocates building community through contribution and engagement in emerging technologies. Learn more about Code at thecodeteam.com. Listen to more episodes of the NewsStack Makers at thenewsstack.io/podcast. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.